Welcome students. Today we are going to see the performance of the practical to study the factors affecting rate of filtration. The requirement for this experiment is in apparatus we will require funnels, suction flask, rubber cork, beaker, measuring cylinder, mortar and pestle, spatula, glass rod and filter paper. In chemicals, we will require calcium carbonate, glycerine, water, etc. So, filtration, it is the process of separation of the solid from slurry by passing through porous medium that retain the solids but allows the liquid to pass through it. This terminology, the terminologies which are used very frequently in the process of filtration includes slurry. Now, what is a slurry? Slurry, it is the suspension of the solid particle in the liquid, right? Now, it is this suspension which you want to filter. Okay, so the suspension of the liquid of the solid in the liquid which you want to filter out or which you want to separate out, it is called as the slurry. Then next, the terminology used in filtration process is the filter medium. Now a filter medium, it is the medium which will retain the solid after you carry out the process of filtration. Okay, so we can say the filter medium, it is used to separate the solid from the slurry. The next terminology used is the filtrate. Now what is a filtrate? Filtrate is the liquid which you obtain after the process of filtration is complete. Okay, so it is the fluid that passes through the filter medium and it is collected in the receiver. It is called as the filtrate. And last terminology which is used in process of filtration is the filter cake. Now what is a filter cake? The filter cake is a layer of the solids which is present in the suspension which is retained on the filter medium. Okay, so filter cake is nothing but a solid that is retained on the filter medium after filtration. Okay, so the process of filtration it include is as when you pass the slurry, okay, over the filter medium, the liquid which is present inside the slurry, it will flow through the filter medium due to the pressure difference across the medium, and gradually the solid it gets retained on the filter medium, which in turn increases the height of the filter cake. So this increasing height of the filter cake, it is going to offer resistance to the flow of the liquid, so that to continue filtration there is a need of higher pressure, to apply higher pressure above the filter medium, and this pressure is called as positive pressure. Or what you can do is you can apply vacuum in the receiver. Okay, so we can say when you apply a suction below the filter medium, that particular thing, that particular process is said to be as application of a negative pressure, right? So why we are either giving a positive pressure or a negative pressure? Because here the rate of filtration, it depends, or it depends on the driving force. Now what is the driving force for the process of filtration? It is the pressure difference. The pressure difference which is upstream, and the pressure which is downstream. Okay, if there is a difference, then only the process of filtration will occur. If there is no pressure difference, then no filtration will take place, right? So either you can increase the pressure on the filter bed or on the filter cake, or you can decrease the pressure in the receiver, in the downstream area, right? So this will assist in the process of filtration. So this is the equipment which is mostly used to carry out the process of filtration. So this is the Buckner funnel. Here you have you can see this is a filter paper, right? Now this Buckner funnel, it has got this cylindrical uh, portion, okay, which helps to carry the filtrate in the receiver, right? Now this receiver, or it is called as the suction flask. Okay, this suction flask, it has got one outlet. Now this outlet is provided for the attachment for the suction pump. When you apply the suction pump here, you are able to decrease the pressure in this area, and because of decrease in the pressure, the process of filtration will be enhanced, right? So when you pack this thing, when you place the Buckner funnel over the suction flask, at that time you have to seal it with the help of a rubber band, right? So in the Buckner funnel, you can observe here, this is the porous plate. Okay, above that porous plate we have placed a filter medium. Okay, and when you pour in the slurry, it will deposit the filter cake on this filter medium, right? So when you pour in the slurry, the cake is deposited, the solid is retained, it results into the cake deposition, and the liquid, it will fall into your receiver, right? So this is the process of filtration. So the rate of filtration, it is expressed as volume of the filtrate per unit time, that is dV by dt. The factor affecting rate of filtration are, first thing, very important one is the driving force for filtration. Okay, the factors which affect process of filtration are, first is the surface area. Okay, the surface area of the filter medium is directly proportional to the rate of filtration. That means we can say, if the surface area is greater, the rate of filtration will be greater. The next is the pressure difference. The pressure difference is directly proportional to the rate of filtration. Then permeability constant of the cake, it is higher is the permeability of the filter cake, higher is the rate of filtration. The resistance of, now we will see what provides resistance for filtration process. The first is the viscosity of the slurry. If more is viscous your slurry, then more amount of time will be required for the process of filtration to complete, right? So we can say the viscosity of the slurry solvent is inversely proportional to the rate of filtration. That is, increase in viscosity decreases the rate of filtration. The next factor which contributes to resistance is the height of the filter cake. Okay, it is inversely proportional to the rate of filtration. That is, increase in the height of the filter cake, it will decrease the rate of filtration. Okay, so on this basis of the driving forces and the resistance, a theory equation is given by Darcy. Okay, so Darcy derives equation for the rate of filtration, and this particular equation is called as the Darcy's equation. Okay, so the equation tells us the rate of filtration dy by dt is equal to K into A into delta P divided by viscosity and length. Okay, so in this case, K is the permeability constant of the cake, A is the surface area of the filter medium, delta P is the pressure difference across the filter medium, that is pressure above the filter medium and pressure below the filter medium. Eta is the viscosity of the slurry solvent, and L is the height of the filter cake. Now we will see how this experiment, how we are going to perform this experiment. Now we are going to see the performance of the experiment for determining the factors which affect the rate of filtration. Okay, so the first part of this experiment, it consists of, like, we have to take three different funnels. Okay, three funnels of different size. We are going to measure the internal diameters of three funnels, and then we will be passing through these three funnels 50 ml of 5% slurry of calcium carbonate in water. Okay, so this is the simple procedure. Then we are going to determine what time is required for the slurry to get filtered from each of these three funnels. That time we have to record, so that we can tell what is the effect of the surface area on the rate of filtration, right? So first we will see what is the diameter of this particular funnel. So if you see this, the internal diameter of this funnel is exactly 12.2 centimeters. So our biggest, or we can say A thermometer, is 12.2 centimeters. Now this second thermometer, which is B, it is exactly equal to 9.6 centimeters. The internal diameter of funnel B is 9.6 centimeters. And now we will see the internal diameter of the smallest funnel, which is exactly equal to 7 centimeters. Okay, so funnel C is 7 centimeters. Now we are going to proceed with the first part of our procedure. So now this is our slurry, 5% slurry of calcium carbonate in water. We have taken 50 ml of that slurry, and now this is our funnel A, okay, which has got the highest diameter. Through this funnel now we are going to pour this our 50 ml of the slurry. Okay, you have to shake the slurry because there is a tendency of calcium carbonate to settle at the bottom.
we have started the time, and we will calculate what time is required for the completion of the procedure. So now if you see here, the filtration has occurred completely, and now we will wait till we get the last drop of the filtrate. Okay, so now our filtration has almost complete. We are also checking the time. So we can say now we have required, so our first filtration through this funnel A, it completed within 3 minutes, and it required 3 minutes and 35 seconds. First filtration is completed in 3 minutes and 35 seconds. Now we have taken our funnel B, okay, and now we will carry out the process of filtration. So again here I am pouring in 50 ml of the 5% of calcium carbonate slurry, and before pouring you have to stir it, because calcium carbonate, it tends to settle immediately. Now we will start the time, and we will check what time is required for the process to complete. So now as you can see here, we have obtained the last drop of the filtrate, and now we are at the end of 6 minutes and 47 seconds. Now we have taken our last funnel, which is of the smallest size, and now we will pour into it the slurry. Okay, remember to stir the slurry every time. Okay, now just pour it, and we will start the timing. We have started the timing. So now as you can see here, we have achieved our last drop. Okay, it just fell, and we are at the end of 8 minutes and 58 seconds. So we can say this filtration it completed in 8 minutes and 58 seconds. Now we will proceed for our part B. Now in our part B, what we have to do, we have to take all the funnels of the same size, okay, and we have to take the slurry of different concentration. Like we have prepared here a 5% solution of calcium carbonate, that is we have dissolved or dispersed 5 grams of calcium carbonate in 100 ml of water. Then 10% solution 10 grams in 100 ml, and 15% solution means 15 grams of calcium carbonate in 100 ml of water, right? Now these are our 3 funnels which have same size, okay, same surface area. So now what we are going to do, through the funnel of the same surface area, we are going to pour this different concentrations of the slurry, and now we will check what time is required for different concentrations of the slurry to completely get filtered. Now we will start with our experiment. So now we will start with our procedure. We have arranged the assembly, and first we are going to pour the 5% solution of the calcium carbonate into the filter paper, okay. We have started the time. Now we will check what time is required for complete filtration. So now, as you can see here, a very small amount of slurry is remaining. Now it will get filtered in just small amount of time. So now, as you can see, we have obtained our last drop of the filtrate. It just fell, and the time required for this is 3 minutes and 4 seconds. Now we are moving to the next thing, subsection of part B. So now we have again arranged the assembly, and now we will be passing the 10% calcium carbonate solution to the filter medium. Okay, now we are going to calculate what amount of time is required for the complete filtration of 10% of slurry. Okay, so again we will stir the slurry and we will pour it. At the time, now if you observe this, okay, we are at the end of the process of filtration. So the time which was required for completion of this filtration was 4 minutes and 47 seconds. So now we are doing the last part of part B, and that is we will be passing the 15% solution of suspension of calcium carbonate through this filter medium, and we will be checking the time which will be required for complete filtration. So now we have started the time, and we will check what time is required. So now we are at the end of the filtration process, and it is completed, and just the last drop has fell, and it took almost 5 minutes and 16 seconds for the process to be completed. Now we are performing the part C. Okay, in part C, now what we are going to do, we are going to determine what is the effect of viscosity on the rate of filtration, right? So for this experiment, we are going to use a single funnel, okay, of a known radius, and we have prepared different concentrations of glycerine solutions in water, and into it we have mixed 5% of the calcium carbonate. That is, first solution is 10% weight by volume of glycerine. In that, using that, we have prepared a 5% calcium carbonate slurry. Then next is 15% volume by volume solution of glycerine in water, and using that we have prepared a 5% slurry of calcium carbonate. And the last one is the 20% volume by volume solution of glycerine in water, and using that we have prepared a 5% slurry of calcium carbonate. Now one by one, using the same funnel, we will filter all these 3 slurries, and we will determine what time is required for individual filtration to take place completely, right? That time we are going to compare. Now we will proceed with our experimental part. Now we will start with our experiment. So first we have taken the 10% volume by volume solution of glycerine and water. So that slurry now we will start to pour in the filter medium, and we will check what time is required for complete filtration. So we have started the time, and we will wait until complete filtration occurs. Now we have completed our first filtration, and the time required for it was 5 minutes and 22 seconds. Now we will proceed with the second part. Now we have taken the 20% volume by volume solution of glycerine and slurry of calcium carbonate. Now we will pour it, we will filter it, and we will record the time required for the same. So now, as you can see here, we have completed the process of filtration, and it took us 10 minutes and 16 seconds for the whole process. Now we have taken our last 15% volume by volume solution of glycerine slurry of calcium carbonate. Okay, now we will pour it through the filter medium, and we will determine what time it requires for complete filtration. We have started the time, and we will record the time. So now our process of filtration is complete, and the total time required for this filtration was 7 minutes and 24 seconds. So now we will proceed towards the observation and conclusion.
Now, based on the practical, we will see the observation table for the same. Okay. So, the first thing what we are doing is to study the effect of the surface area on the rate of filtration. So, if you observe this observation table, here we have serial number. This is the funnel which we have used. Its internal diameter, average diameter, radius, surface area, volume of slurry, time, and the rate of filtration. Right. Now we first took funnel A, and we measured its diameter. Okay, we measured it thrice, and then we have taken average of it, and then using this diameter we have calculated the radius. The same thing is done for B, and same thing is done for C. Okay, now from the radius we are using the radius, we are going to determine the surface area. Okay, now your funnel, it is circular, the area is circular, so we can say the area of funnel will be calculated using the formula pi r square. Right, now we have the radius, we know what is the value of pi, we have calculated the area. Okay, now this is the 19.15 is the area of funnel A, 15.07 is the area of B, and 10.99 is the area of funnel C. Right, now in each funnel, in each the amount of slurry which we had taken was 50 ml. Okay, the time, okay, now after that we calculated what time was required for the complete process of filtration. Okay, so for A, okay, it took almost 3.35 3 minutes and 35 seconds. For time for funnel B, it took 6.47 minutes, and for C, it took 8.58 minutes. Right, so now we will calculate the rate of filtration. Okay, the formula for rate of filtration is volume of the slurry divided by time. Okay, so for the rate of filtration is volume of the slurry divided by time. So for A, the volume was 50 ml and the time was 3.35 minutes. Right, so we by performing the calculations we get the rate of filtration to be 14.92. For B, the time was 6.47 minutes. So after calculation we get rate of filtration to be 7.72. And for C, time was 8.5 minutes. So after calculation we get the rate to be 5.827. Okay, so these are the rates and which we have put here. Okay, so mere by observation you can tell that this particular rate of filtration is the highest. Okay, now if you see back, it has got the highest surface area. This rate of filtration is the least. Why? Because the surface area here is least. So directly from this observation we are going to conclude that with increase in surface area the rate of filtration is going to increase, right? Then next, now we'll see the next table, and it is to study the effect of height of the filter cake, or we can say to study it is a factor which is affecting the rate of filtration is the amount of your suspended particles present in the suspension, right? So for this we have used only one funnel. So we prepared a slurry of 5%, 10% and 15%. The whole volume of 50 ml was passed every time of 5%, 10% and 15% through the funnel A, right? So for 5% slurry, time required was 3.04 minutes. For slurry 10%, time required was 4.47, and for 15% concentration, time required was 5.616. Okay, so based on this values, we have performed the calculation. Now the formula to calculate the rate of filtration is volume of the slurry divided by time, right? So for 5% suspension, rate will be 50 divided by 3.04. It comes 16.447. For 10%, 50 divided by 4.47, it is 11.18. Then for 15% solution, rate is 50 divided by 5.16, it gives you 9.689, right? So we have put these values in this table. Okay, now by just mere observation you can tell that with increase in the concentration of the calcium carbonate in the suspension, the rate of filtration decreased, right? Now next, the last thing is to study the effect of viscosity. Okay, so we prepared a blend of glycerine and water which was of 10% volume by volume, 15% volume by volume and 20% volume by volume. We used a single funnel for that, right? Every time. So we prepared a 5% slurry of calcium carbonate in this glycerine and water blend. So that suspension, that 50 ml suspension, we passed it through the funnel, through the filter medium, and we calculated the time. Okay, so for 10% volume by volume, it took 5.22 minutes. Then for 15% volume by volume solution, it took 7.24 minutes, and for 20% volume by volume, it took 10.16 minutes, right? So again we will calculate the rate of filtration using the formula volume of slurry divided by time. Okay, so we have put the values for each of the blend, and then we the values which we get for the rate of filtration, those we have put in this table, right? Now only by just observing this table you can say as the viscosity of the liquid it increased, the rate of filtration it decreased. Okay, so in the result we are just going to state the rate of filtration increases with increase in the surface area of the filter medium, the rate of filtration decreases with increase in the height of the filter cake, and the rate of filtration decreases with increase in the viscosity of dispersed medium of the slurry. So in this way we are going to report our results, right? Now the most commonly asked questions for this experiment of filtration is either you will be asked to define filtration, then you will be asked to tell what is the difference between filtration and clarification. So the difference between filtration and clarification is that the process is same. Okay, how you perform the process, that is exactly equal, but the major difference is that when the solid content of the slurry is less than 1% weight by volume, and if you carry out the process for this so dilute suspension, that process is termed as clarification. And when the concentration of the solute or the suspended particles is greater than 1%, At that time, the process of separation is called as filtration, right? Then the next frequently asked question is, you will be asked to explain the factors which affect the rate of filtration. Okay, so the factors which affect the rate of filtration are, the first thing is time. If you uh, carry out the process of filtration for a long time, then it will be more efficient. Then second is surface area. You increase the surface area, the rate of filtration increases. Next is pressure difference. You increase the pressure difference, the rate of filtration increases. Then viscosity. Lower is the viscosity, more is the rate of filtration. Then concentration of the solute. More concentration of the solute is present, the less is the rate of filtration. Okay. Also, but temperature will also affect the rate of filtration. The more is the temperature, the more will be the rate of filtration, right? The next question asked is about the filter aids. Explain filter aids and how are they used. So the basic use of the filter aid is that it avoids the um, your filter medium from clogging or plugging, and also it forms a very porous cake which itself will act as a filter medium for the further process, right? Now, filter aids you can use in two ways. The first method is pre-treatment or pre-coating treatment, and the second method is body mix technique. Okay. Then next question which is very commonly asked is, what are the applications of filtration? So you can say that filtration is used to carry out produce bulk drugs. Then also it can be used for preparation of sterile products. The HEPA filters are used, laminar air bench is used for the same purpose. Also filtration is used for effluent and wastewater treatment process. Okay, so these are the different applications of the process of filtration. So this was all about the experiment of factors affecting rate of filtration. Thank you.